Okay, this is part 2 of the Bodkin's Kickstarter CFL circuit. His circuit's a little different than mine, but I named this after him. Anyway, I'd made a mistake on my last posting, and I hope I've corrected it with everybody. I showed a connection here between the base and the collector, and that's not there. So I hope no one else tried to build this last night and had trouble with it. One of the guys already complained it wouldn't run, and that was the reason. There's no connection between there and there. And the one I showed yesterday had two of these 2N3055 transistors. And today I decided, you know what, I wonder if it'll run with a smaller transistor, but a similar one. So I got a couple of these TIP3055s, and I had another one of these rheostats, and I just built the whole thing as one little piece right there. That's the whole circuit right there. There's no transistors, there's no there's no capacitors, there's no resistors, except for the potentiometer, which controls the drive voltage. And the way these are set up, they're set up back to back. And John Bedini said keep all of your connections as close as possible, because all of this stuff works together. And this might be true for this circuit too, but anyway, it runs. And thought I'd show you what I found out. I also worked on recovering some of this energy that's coming off of this coil. When this thing charges and collapses and charges and collapses, it puts out a lot of high voltage all over. And I discovered one place where we can pull it off, right here at the battery. And I just used some big diodes, one shooting it up this way from the positive, and one shooting it back in from the negative. And this is the only way it would work for me to load up a capacitor. But I'll show you how that works. This is my amperage draw on the system. And this right over here is the voltage on this capacitor. This is a 2200 microfarad 50 volt cap that's going to receive the energy from this point in the circuit. There's voltage on the drive source battery. It's a little less than 13 right now. And let me turn this on. I'll show you how this works. This is the same circuit as this one right here. And it is posted at the energetic forum. And what I'm going to do is I'll pan this so you guys that can't see the circuit at the forum can duplicate this perhaps and look at it. But it has a little kickstart here. Bodkin's kickstarts his using the base to the ground or a base to an antenna. Mine, you have to actually tap it with some source voltage, or sometimes it just self-starts. But it's extremely simple. It is an oscillator circuit that uses the two coils in that ignition coil and goes into self-oscillation. Okay, to start mine, I'm just going to connect it right here. And there goes one bulb. I'm going to crank up, and there goes the second bulb. Here's my amperage draw right now. I'm drawing 130 milliamps on the system. Now over here, I can dial this up or down. Show this and increase brightness and amp draw. I'll put this up about 3500, and there's my brightness on it. I'll dial this down again here. Dial this up, and it gets pretty darn bright. If you want it bright, you can make it bright, but it costs you a lot of juice. There's about 600 milliamps to get the full brightness, but it's there. And I do like the fact that if you want the brightness, you can make it for a little less than an amp. I'll put this back down here a ways. Okay, now this was the second part that I worked on today, was the energy recovery. Now I've got these this capacitor zeroed out. I don't know if you guys can see that or not. Wow, got a light on it here. There. Okay, there's nothing on the cap right now. It's grounded out. I'm going to put the cap to the same potential as the battery right here. Okay, that is the voltage at the battery right now. This is going across from here to here, and that's what's in the battery reflected at the capacitor voltage right here. Now what I'm going to do, because there is high voltage here, and I'll show that with this. This is a neon right here. And watch the neon when I tap this. See if I can get that. You see that come on. And you'll get shocked if you touch this. And this is coming off the earth ground. The earth ground makes this happen. and the earth ground is coming in through here into the circuit right there where the CFLs are. And anyway, what I'm going to do now is, there's voltage again on the capacitor. That's this one right here, the 2200 microfarad 50 volt. I'm going to connect the circuit so that it pumps. This is a diode going out. This is a diode going back in. And there goes the voltage. And this will climb right on up, and it keeps right on climbing. This is pumping voltage into this capacitor. And it just keeps pumping right on up. Now, another thing I did today was I put a high voltage, low capacitance capacitor on this circuit, and it would pulse. I got it to pulse with a neon at about 60 volts. It'd go on up to 60 volts and sit there and pump with this little neon. So there's possibly a way we can take the neon or a cap pulsar circuit and take this energy and put it into a battery using a cap pulsar. But yeah, this, like I say, is a way to get this energy that's coming in here and pump it into a capacitor. Take the energy that's in the capacitor and then you dump it into a battery. I tried putting this straight into a battery. It didn't go real well. For some reason, I think it has to go into a capacitor first, and I'm not quite sure the dynamic of that, why that works. But this was successful. It was a way to get it off. And I tried it all over the circuit, tried getting this energy off all of the circuit, and this was the place I found where I could actually get it to go into a capacitor and it would stay. So anyway, that is the circuit for today. And like I say, this part right here, if you guys want to make this, just make sure you keep your drive draw down a ways. This will get hot. This rheostat, this 25 ohm rheostat, without a heat sink on it, gets pretty hot. Now the transistors seem to run just fine. You'd think they get hot, but at this less than half an amp, everything seems to run pretty darn cool. But that's the whole thing right there. That's the whole darn circuit, except for the ignition coil. And the CFLs, by the way, are part of this. If you don't have these CFLs in series, they have to go in series, and you can do a whole bunch of them. But as you drop down in bulbs, the amp draw goes up. As you go up in bulbs, the amp draw goes down. And I actually think you can get more light by using more bulbs. And if you don't have the right impedance rating on this to match up with your coil, this thing doesn't run very well. So just a tip for the guys struggling with this, that try switching some bulbs around. But there's the voltage still climbing on the cap. And like I say, I just left this alone. It just kept climbing right on up, and depending on the size of your cap and the rating on it. So anyway, that's the latest for today.